In my previous lecture, I discussed about the atom and the fundamentals of the atomic structure. And today's lecture plan will be Bohr's model of the atom, hydrogen spectrum and Bohr's theory, success of Bohr's theory, limitations of Bohr's theory and Bohr-Bury scheme. The Bohr's model of the atom. In 1913, Niels Bohr proposed a theory of hydrogen atom to explain the origin of hydrogen spectrum, and Bohr's theory is based on the following four postulates. A hydrogen atom consists of proton and an electron moving around the nucleus in a circular path called orbit, radius r, or stationary states too. Bohr's model of the atom, the force of attraction F between the electron of mass m and charge E and proton of charge Ze, where Z being the atomic number and E being the charge of a proton. So, that can be given by the Coulomb's law of electrostatic attraction, F is equal to Z square upon R square. This force just balances the centrifugal force of electron, that is mv square upon R. Hence, mv square upon R is equal to Ze square upon R square and V square is equal to Ze square upon mR square, or half mv square is equal to Z square upon 2R, where V is the velocity of the electron and half mv square is the kinetic energy of the electron. The energy associated with each orbit was governed by the condition that angular momentum of electron must be an integral multiple of h upon 2 pi. The momentum of the electron is given by mvr is equal to nh upon 2 pi, where h is the Planck's constant and n is an integer 1 to 3 called principal quantum number of electron orbit. V square is equal to Ze square upon mr and V square is equal to n square h square upon 4 pi square m square r square. From the above equations we can get Rn is equal to n square h square upon 4 pi square m Z e square. This equation, hence the radius of the first orbit R1 for the hydrogen atom n is equal to 1, Z is equal to 1 can be calculated out. This equation R1 is equal to h square upon 4 pi square m e. The radius of the first orbit of hydrogen atom is known as the Bohr's radius, R1 or RH or A0. Thus, Rn is equal to n square R1. In SI system, the charge E replaced by E upon 4 pi epsilon 0, where epsilon is a constant and called permittivity of the medium. Its numerical value is 8.8542 into 10 raised to the power minus 12 coulombs square per Newton per meter square. The factor is known as permittivity factor. Its numerical value is 1.11264 into 10 raised to the power minus 10 coulombs square per Newton per meter square, which is equivalent to n square h square upon 4 pi square m Z square. Thus, in SI system, this above equation may be written as Rn is equal to 4 pi epsilon n square h square upon 4 pi square m Z square. The value of Rn can be calculated by substituting different values in the above equation. In CGS system, the Rn value can be calculated by this equation, by these values. So, R is equal to n square into 0.5 0.29 into 10 raised to the power minus 8 centimeter, or R is equal to n square into 0.529 angstrom. In SI system, Rn value can be calculated by these values, and we can get Rn value is equal to n square into 0.529 into 10 raised to the power minus 10 centimeter. Now, on putting the values of n 1, 2, 3, 4, 5 etc., the values of R1, 2, R2, R3, R4, R5 etc. can be calculated. These values are given as 0.529, 2.11, 4.75, 8.45 and 13.22 angstrom respectively. The energy of an electron in a given orbit is fixed. The total energy of the electron E is the sum of its potential energy minus E square upon R and its kinetic energy half mv square. So, therefore, we can get the energy from this equation E is equal to minus Z square upon R plus mv half mv square. From these equations, we can get finally the equation Z square upon R plus Z square upon 2R is equal to minus Z square upon 2R. Putting the values of R from the equation above, we can get finally this energy calculation equation En is equal to minus 2 pi square mz square e to the power 4 upon n square h square. So, this is the final equation for getting the energy of an orbit. The above equation is known as Bohr's equation, applicable to hydrogen and hydrogen like ions only, such as helium positive, lithium bivalent and beryllium trivalent ion etc. having different values of Z, but one electron only. So, this equation in SI system, this above equation may be written as like this, and the value of En can be calculated by substituting the different values in the above equation in SI system. In CGS system, minus 2 pi square mz square e to the power 4 upon n square h square, the En value can be calculated by these values. Finally, we can get the energy of the orbit is equal to minus 2.179 into 10 raised to the power minus 11 ergs per atom upon n square. So, in SI system, this equation gives you the value finally by these parameters. Finally, we can get this equation, this E energy, that is of an orbit, defined orbit, whether it is 1, 2, 3 or like this, is equal to minus 1313.315 kilojoules per mole upon n square. Now, on putting the values of n 1, 2, 3, 4 etc. in this equation, En is equal to minus 2.179 into 10 raised to the power minus 11 ergs per atom upon n square. The values of E1, E2, E3, E4 etc. can be calculated. These values are as follows, like this in ergs per atom respectively, and in SI system these values are this in kilojoules per mole respectively. If E1 is the energy of the first orbit and E2 is that of the second orbit, then in a jump from E2 to E1 energy level, which is called transition or the frequency transition, the frequency of light emitted is given by this equation, by the Planck's Einstein equation. H nu is equal to E2 minus E1. By substituting the values of E1 and E2, we get minus 2 pi square mz square e to the power 4 upon n square h square into 1 upon n1 square minus 1 upon n2 square. As we know, nu bar is equal to 1 upon lambda. So, we can get this equation finally, and where the c is velocity of light, nu is the frequency of the light emitted, and nu bar is the wave number. So, nu bar is equal to 1 upon lambda is equal to r into 1 upon n1 square minus 1 upon n2 square, where r is the Rydberg constant. R is equal to 2 pi square mz square e to the power 4 upon h cube c. By putting the values of different constant in this equation, we can get the Rydberg constant by putting these values equivalent to 109,679 centimeter inverse. The Rydberg constant for hydrogen atom RH is equal to 109,679 centimeter inverse is in excellent agreement with experiment value 109,677.8 centimeter inverse. Velocity of electron in various orbit of hydrogen atom may be calculated likewise. According to equation mvr is equal to nh upon 2 pi or v is equal to nh upon 2 pi mr, we can get the value of Vn by putting these values. Finally, we can get 2.188 into 10 raised to the power 8 centimeter per second upon n. On putting the values of n1, n2, n3 and 4 etc. in the above equation, the value of velocity of electron in first, second, third and fourth orbit can be calculated. These values are 2.188, 1.094, 0.729, 0.547 into 10 raised to the power 8 centimeter per second respectively. A hydrogen atom contains only one electron, n is equal to 1, and moves without radiating energy. However, if the electron absorb energy in some way, it becomes excited and moves to a higher energy level, n is equal to 2 or 3 or 4. This excitement can be brought either by heating or by collision etc. When energy is supplied to the sample of hydrogen gas, individual atom absorb different amount of energy. Some atoms absorb so much amount of energy as to shift their electron to second energy level, n is equal to 2, while some may absorb more energy and shift their electron to third energy level, n is equal to 3 and so on. So, thus n is equal to 2, 3, 4 can be calculated out. Evidently, the electron in higher energy level are relatively more unstable than lower energy level. Therefore, these electrons come back to their ground energy level in the n1 n is equal to 1 or higher energy level by emitting different amount of energy. These electronic transitions give the values of n1 and n2. For example, Balmer series which appears in the visible region varies when the electrons jump from n2 is equal to 3, 4, 5 to n1 is equal to 2. In the same way, the values of n1 and n2 can be calculated for all the 5 series with the region in which they appear. This is the explanation of region of hydrogen spectrum on the basis of Bohr's theory and shown in the figure. The region of the hydrogen spectrum as shown here, the Lyman series, Balmer series, Paschen series and bracket series. According to below equation, which is derived by Bohr's theory, the nu bar can be calculated out 2 pi square mz square e to the power 4 h cube c into 1 upon 1 n1 square minus 1 upon n2 square. The success of Bohr's theory may be explained on the following facts. This theory gives the clear explanation of emission and absorption spectrum. The experimental and calculated values of the frequencies of various spectral lines of hydrogen spectrum are in good agreement. The values of Rydberg constant for hydrogen RH as calculated is this one in centimeter inverse, while in experimental value is this one in centimeter inverse obtained from spectroscopic studies. Both these values are in good agreement. The value of radii and energies of different orbits as calculated from Bohr's equation are in good agreement with the experimental values. This theory is the basis for the Ridge combination principle. The ionization energy of hydrogen can also be calculated out. The table shows the experimental values and calculated values of the Lyman series, Balmer series and Paschen series. Experimental values for Lyman series 82.2 into 10 raised to the power 5 and calculated values 82.2 into 10 raised to the power 5, while Balmer series is also giving experimental values 15.2 into 10 raised to the power 5 and calculated values in the Balmer series are 15.21 into 10 raised to the power 5. Experimental values for Paschen series 5.32 into 10 raised to the power 5 and calculated values 5.30 into 10 raised to the power 5. Likewise, we can see that these are all in agreement with the experimental and calculated values. Although there are so many facts in favor of Bohr's theory, even then it had certain shortcomings or limitations, which are: it explains only the spectra of element or ions which have only one electron, as for example hydrogen, helium cation, lithium divalent cation, beryllium trivalent cation, etc. It does not explain that how the radiations occur in the atom. Refined or resolved spectroscopic analysis showed that the line observed in the spectrum of hydrogen are not single, but they consist of a number of component lines lying close together, known as fine structure. In terms of energy level, we can say that there are a number of energy levels very close to one another. Bohr's theory failed to explain the existence of fine structure. The pictorial concept of electron jumping from one orbit to another orbit is not justified because of the uncertainty of their positions and velocity of electron cannot be evaluated simultaneously. This theory is based on two opposite theories, that is quantum theory, which deals with the existence of stationary orbits and for frequencies of radiations emitted, and laws of classical mechanics, which deals the motion of electron in its orbit. This theory does not explain the Zeeman effect and Stark effect, which explain the effect of magnet and electromagnetic field on the lines of a spectrum. In 1921, Bohr and Bury simultaneously put forward two identical schemes for the arrangement of electrons in an atom, which is as follows. Number 1, the maximum number of electrons in which each orbit can contain is 2n square, where n is the number of orbit. Thus, the maximum number of electrons in the first, second, third, fourth or etc. orbits are 2, 8, 18, 32 respectively. The maximum number of electrons in the outermost orbit is 8 and in next to the outermost orbit is 18. It is not necessary for an orbit to be complete before another commences to be formed. In fact, a new orbit begins when the outermost orbit attains 8 electrons. Next point, the outermost orbit cannot have more than 2 electrons and next to the outermost orbit cannot have more than 18, so far as the next inner orbit in each case has not received the maximum number of electrons as required by the rule 1. As you know that I have discussed in brief about the Bohr's models and its limitations and how to calculate the energy and radius of the orbits. In this way we can say that you will better understand this atomic structure by listening some more lectures, and in the next lecture I will discuss about the de Broglie's equation and uncertainty principle. Thanks.